Yes. For the X-ray point, you would about 8 to 12 foot, probably about 8 feet thick. Okay, so the reason you see here it's serpentine is because it is not to keep the E-beam inside. It's really when the electron beam hits the conveyor belt of metal, it gives off Bremsstrahlung radiation. It gives off spurious X-ray. It's to prevent the X-rays from coming out. That's why you have 3 right angles. It's for to keep the X-ray inside. So this is the actual scan horn from which the electrons come out. And so this conveyor belt is always running at a particular speed. I think it's 60 feet per minute. But this is the conveyor belt that is actually calibrated to the dose you want. So if you want high dose, you make it go slower. So you can see here there is this one conveyor belt here, and this is the underbeam conveyor. So the underbeam conveyor is the one that is calibrated and connected to the dose. So this is the electron beam from the top. Here you have on the side, that's the 5 MeV X-ray on the side. I mean, when you want to run X-ray, we just run the 5 MeV X-ray. Similar to this, so this is a 10 MeV 15 kilowatt accelerator scan horn. You see the space between the beam, between the conveyor belt. Similarly, there's a space there. The reason for that is there's an accelerator that's pointing up. Remember yesterday's conversation, they said, do you want it sideways or top? Now that's a discussion that has to be carefully thought through, because there is a disadvantage when you have top. It may appear to be good top and bottom, but you see, if you have a conveyor from the top, you are limited by the height of the box. Okay, there's a limitation because if the box is large. But it is a lot easier than the carriage that was said. You can put your products in it goes going in and out. There's no other system. There's potentially less complication. But there's also another challenge when you have the beam from the bottom, because if your product has grains or seeds, if it breaks, those seeds will fall on the window and that will catch on fire. If that window catches on fire, you're going to have a catastrophic failure of accelerator, and that is a lot of money, a lot of damage, downtime. So you have to think through carefully what is it that you want. So here, if you see, we have trays which have completely solid base. That is good for saving the accelerator, but it will not allow the beam to penetrate much. So we are now trying to get a different type of tray with holes in it, but we are very concerned that when we do the bit, we cannot afford a situation where things leak and fall in. So you have to think about what sort of configuration you want. Okay, so there's a lot of control systems, so every box is counted. That's the process control. Every box is counted. If there's a stoppage here, the whole beam will stop. The reasons you have these type of things is so that the boxes, when they come, remember humans are putting the boxes as trays. When it comes here, it straightens it out and goes.
Orienting the trays, this kind of brackets you use.
For
orientation?
Yeah, for orientation purposes, because when you want the whole carrier to be
center.
Yeah, because you don't want to waste the beam.
Yes.
The beam is precious, so you want to keep as much of the space being used.
So optimizing the
Yeah.
beam use.
Yeah.
The
whole is for there's a red light here. It's counting the boxes, because in the process control, the operator says, I have 400 boxes. And it's counting whether 400 boxes have gone through. There's a similar counter there. We will say if only 300 boxes came, what happened to the 100? That will tell you that there's a fault, that something is stuck.
Optical sensor.
It's an optical sensor, yes. And then here on the floor is a hole for the ozone. So when this facility is when this place is operating, obviously there's a lot of ionizing radiation, but there's also ozone in here. That's why the plastic curtain is there to keep the ozone from going out. Also, there is a fan that will suck the ozone from this area out. Okay? Any questions? All right, thank you. I will bring the next group in.